Welcome to Spring LIB.
Hello student. So the question is to find the free energy change of the reaction when the reaction where the A is the reactant and B is the product. So this is the reaction, and first we have been given the delta G is 0 kilocal per mole when the temperature is 37 degrees Celsius and the concentration of an A and B is 10 molar and 0.1 molar respectively. So now the conditions are, the second conditions are, now the concentration of A is now 0.01 molar and the concentration of B is 1 molar. So now we need to calculate the free energy of the reaction when the concentration is now different. Now we will be using delta G is equal to minus of R T ln of K. So this is the formula. Now here let this delta G be delta G1 and let this delta G be delta G2. So from here the R is the universal gas constant and it is equal to 1.987 kilocal, not kilocal but cal, 1.987 calories per mole per Kelvin, and here T is 37 degree Celsius. Now we need to convert this into Kelvin. So we'll add 273 Kelvin and it is equal to 310 Kelvin. So now let's put the values. So here the K is the gas is the equilibrium. K is the equilibrium constant and K can be calculated by using this formula. Here the K is equal to the concentration of the product, which is B, divided by the concentration of the reactant, which is A. So by putting the value, we'll get the K and it is equal to, so here the concentration of B is 1 molar and the concentration of A is 0.01 molar. So by calculating it, we'll get 100. Now let's put the value over here. So here the delta G2 is equal to minus of R, which is 1.987 calorie per mole per Kelvin, multiplied by the temperature, which is 310 Kelvin, multiplied by the ln of K, which is 100. So now let's calculate it. So we'll get delta G, which is equal to minus of 2836.5 cal per mole. So to convert it into kilocalories, we'll divide this with 1000. So it is equal to minus of 2.8365 kilocal per mole. Now we'll see the change in free energy when the conditions are different for different delta G. So now the free energy will represented by delta G dash and it is equal to delta G1 minus the delta G2. Now let's put the value. So here the delta G1 is 0 kilocal per mole minus the delta G2 value, which is minus of 2.8365 kilocal per mole. So now by calculating, we'll get the delta G dash, which is the free energy change in free energy, and it is equal to plus of 2.8365 kilocal per mole. So this is the answer. I hope you find this video helpful. Thank you.